guys, welcome back from the holiday break. I know you're so excited to watch the video tonight. So today we're going to be doing a little bit with adding and subtracting radical expressions. So in order to add and subtract or to combine a radical expression, they have to have the same number underneath the radical. So these both have to be a 2 if you're going to combine these. They must also be the same type of root. In this unit, we're just going to be dealing with square roots, so you don't really have to worry about that. But for example, you couldn't combine 3 root 2 minus 5 cube root 2. That you're not allowed to do. But you're not going to see them in this chapter, so you don't really have to worry about that just yet. So now let's try to talk about how we would combine these two expressions here. Because these are like terms, here I have 3 roots of 2, and I want to take away 5 roots of 2. So I have left over negative 2 root 2. I'm only able to do this because I'm combining apples with apples. I couldn't do this if I were to do 3 root 2 minus 5 root 7, let's say. Now I can't combine apples and oranges. So let's try another example. So initially this looks like you're not able to combine these two radical expressions because they don't have the same number under the square root. However, one of these square roots can be simplified. So root 8 can be broken up into 2 root 2. Now, 2 root 2 times this 10 on the outside is really 20 root 2. Now, I am able to combine it with this 4 root 2 with a result of 24 root 2. Pretty easy. So now let's try the next one. So here I have 2 expressions where some of the parts are just regular integers and some are square roots. So I know that I can combine this 6 and this 4. So I have 10 plus root 12 minus root 75. Now let's see if I can do anything with those radicals in order to be able to bring them together. So I can break up 12 into a perfect square of 4 and then 3. I can break this up into a perfect square of 25 and then 3. So if you see, I have a perfect square and then the same other number. That's going to allow me to combine these roots eventually. So this ends up being 2 root 3 minus 5 root 3. Now I can combine these two together because they're like terms. I'm going to get 10 minus 3 root 3. And that's your answer. So you can also perform this operation if you have a variable under the square root. So for example, here I have root x, and root x. So because they're all the same thing under the radical, it works just the same way that numbers do. So here I have 7 root x. I want to take away 3 of them. So I have 4 root x's left over. Now I want to add 1, so I have 5 root x. And that's our answer. So now let's do our joke of the day. So a blonde woman and a brunette woman were taking a walk. The brunette goes, "Oh, look, there's a dead bird." And the blonde looks up in the sky and goes, "Where?" All right, so now the next one. So one more example. So here I have more complicated expressions under the radical. So let's see if I can simplify them. So here I have 100, which is a perfect square, and x squared, which is also a perfect square, meaning that you can take the square root of it. So this square root of 100 x squared is just 10x times 3x. Now, here I have the square root of 25x squared. That's really just 5x. And here the square root of 36x squared is really just 6x. You do have to be a little bit careful with the signs of x here. Technically, this is really the absolute value of x in each of these expressions here. But I'm going to let your pre-calc teachers deal with that with you so that maybe we can understand this a little bit better. So here I have 3x times 10x, which is just 30x squared. 2x times 5x, which is just 10x squared, plus 6x. So So now I'm going to try to combine these two together because they're like terms, and I get negative 7x squared plus 6. And that's our lesson for today. Don't forget to answer those questions.